My name is Ravinder Singh. My matrix number is 200448.
Today I'm going to talk on the introductory part of electromagnetic interference and electromagnetic compatibility. So let us begin with electromagnetic interference. What is electromagnetic interference? Electromagnetic interference, EMI, is the interference caused by one electrical or electronic device to another by the electromagnetic field set up by its operation. So EMI is also described as the disruption of operation of an electronic device when it is in the vicinity of an electromagnetic field in the radio frequency spectrum that is caused by another electronic device. So by the name of interference given to it, EMI is an unwanted signal at the signal receiver, and in general methods are sought to reduce the level of interference. There are many forms of electromagnetic interference, EMI, that can affect circuits and prevent them from working in the way it was intended. The different type of EMI can be categorized in number of ways. So the first one, EMI, electromagnetic interference, can arise from either man-made or natural. So let us see for man-made EMI. This type of EMI generally arises from other electronic circuits, although some EMI can arise from switching of larger currents. The second one is naturally occurring EMI. This type of EMI can arise from many sources such as cosmic noise as well as lightning and other atmospheric type of noise. Other than that, we can also categorize EMI by its duration. So the first one is continuous interference. This type of EMI generally arises from a source such as a circuit that is emitting a continuous signal. However, background noise, which is continuous, may be created in a number of ways, either man-made or natural occurring. The second one is impulse noise. Again, this type of EMI may be man-made or naturally occurring. Example of impulse noise are lightning, electrostatic discharge, ESD, and switching system that will contribute to the impulse noise, which is form of EMI. So now we will see for electromagnetic compatibility. What is electromagnetic compatibility? Electromagnetic compatibility, which is also known as EMC, is the ability of different electronic devices and components to work correctly even in the presence of other devices that emit electromagnetic wave. Electromagnetic compatibility is also an entire branch of electrical engineering, a field of study concerned with the unintentional generation, propagation, and reception of electromagnetic wave that cause unwanted effect on electronic equipment such as electromagnetic interference, EMI, or even physical damage. So there are two main elements to EMC. The first one is emissions. The EMI emission refer to the generation of unwanted electromagnetic energy. This need to be reduced below certain acceptable limits to ensure they do not cause any disruption to other equipment. The second one is susceptibility and immunity. The susceptibility of an item of electronics to EMI is the way it reacts to unwanted electromagnetic energy. The aim of the design of the circuit is to ensure a sufficient high level of immunity to these unwanted signals. So in other words, we can say that electromagnetic compatibility aims to control the damaging effect of EMI in order to mitigate risks of equipment damage. Also, we can say that this means that each piece of equipment emitting electromagnetic wave or disturbance must have its limitation to a certain level, and that each individual device must have adequate immunity to electromagnetic disturbance in the environment it is meant to function in. So that's all from me.
Hello guys, so in the last part we discussed about the definition of electromagnetic compatibility and the definition of electromagnetic interference. Now, I would explain on the electromagnetic interference specifically in commercial buildings. My name is Kaviraj, son of Anbalagan, and my matrix number is 203706. Let's get started. As mentioned earlier, any electronic device may be the source of EMI, although this is not the intention of the designer. The cause of the EMI problem may be either within the system, in which case it is termed as intra-system problem, or from the outside, in which case it is called an inter-system problem. This diagram shows the examples of inter-system EMI problems in general. The letters E and S denotes the emitter and susceptor. The term emitter is commonly used to represent the source of EMI, while the term susceptor is used to designate a victim device. Some of the examples of EMI sources shown in this diagram are computers, power lines, radar transmitters, and so on. The origins of EMI are basically undesired conducted emissions, which can be voltages and currents, or radiated emissions, which can be electric or magnetic fields. Conducted emissions are those currents that are carried by metallic paths and placed on the common power network, where they may cause interference with other devices that are connected to this network. Radiated emissions concern the electric fields radiated by the device that may be received by other electronic devices, causing interference in those devices. Now, the focus of the video is to spread awareness on the electromagnetic compatibility in commercial buildings. Now, what are commercial buildings? A commercial building is defined as one in which at least 50% of its floor space is used for commercial activities such as retail, the providing of services, or food service such as restaurants and the like. Additionally, a commercial building may also be defined as a space that has the potential for being one that brings in income. It is a space that allows companies to carry out day-to-day operations and serve customers or clients. This indicates that the scope of commercial buildings are wide, and there can be a lot of sources producing electromagnetic interference. Virtually, all commercial buildings have areas with elevated AC magnetic fields which are 60 Hz of power frequency that can cause interference problems with sensitive electronic equipment and may be of possible health concern when continuously occupied. These are unavoidable as they are caused by electrical distribution equipment such as transformers, distribution switchboards, distribution service panels, and distribution electrical feeders or conduits. Most commercial buildings have background fields in the range of 2 to 4 milligauss, but also have areas containing hotspots with much higher readings near these current sources. With today's increasingly sensitive electronic technology, even relatively low background fields may be sufficient to cause equipment interference. Due to the close proximity of sensitive devices to noisy sources, the leading modes of EMI are capacitive and inductive coupling amongst cabling and harnesses. Capacitive coupling is more of a concern in high voltage circuits, while inductive coupling is more of a concern in high current circuits. Examples of switching loads which are inductive or capacitive are electric motors, transformers, lamps, ballast, and power supplies, which can cause electromagnetic interference, especially at currents above 2 ampere. Alright guys, that concludes our discussion on electromagnetic interference in commercial buildings. Thank you for staying up with me guys.
Assalamualaikum. My name is Nur Najwa Azira binti Murad with matric number 203731. I'm here to introduce about case of EMI. Electromagnetic compatibility (EMC) is an emerging issue for electric utilities and those who use electronic equipment. It refers to the ability of a device, piece of equipment, and system to function satisfactorily in its electromagnetic environment without introducing any intolerable disturbances, or we call it as electromagnetic interference (EMI). Although these EMI investigations are more complex than the traditional harmonics or transient investigation, they make up the majority of cases we see and read today. the increasing number of offline and online sources of EMI, plus the variation in equipment immunity to these sources, are producing new cases of EMI. The type of emission generating equipment are also growing with the level of radiated and conducted emissions generated by this equipment. As you know, EMI can lead to process interruptions and shutdowns that reduce product quality and productivity, jeopardize personal safety, and negatively affect the bottom line. Thus, locating emission sources and identifying solutions to eliminate and prevent EMI problems create challenges for power quality investigators. Since our topic is about commercial building, let us talk about the case regarding theft detection system in some of the department stores in a shopping mall. The case goes by when several department stores in a shopping mall experience problem with their theft detection system. This system transmits a burst of radiated electromagnetic energy into the air near the store entrance and wait to receive an echo response from the detection tag attached to the merchandise. If the salesperson did not deactivate the tag, the detection system received an echo frequency of about 57 kHz. So, to solve the problem, investigators conducted an EMI analysis to determine the source of the problem. They ran a series of basic tests inside the store and identify conducted emissions propagating through power conductors under the floor beneath the system. These frequencies then radiated through the air and coupled into the pickup loop antenna of the theft detection system. The source was a set of conductors that provided power to the adjustable speed drive AST, used in the heating, ventilation, and air conditioning system located at the other end of the mall. Located close to the theft detection system, these conductors create interference that saturated the amplifier in the first stage of the detector. To conclude the case, a manufacturer designed a filter matching the unbalanced impedance of the branch circuit to attenuate the conducted emissions from the EST. This same design was successfully applied to the other locations experiencing theft detection system malfunctions. This case study shows how EMI can create havoc with power electronics. They also demonstrate that the source of the interference can come from the electronic device themselves. As long as the number of sensitive equipment and EMI sources continue to rise, so will the number of malfunction and complaints. But with a proper understanding and systematic investigation methodology, we can identify, solve, and prevent the EMI problem that are bound to happen.
Everyone, my name is Fine. My matrix number is 20259. Today, I will talk about the solution of EMC to solve the problem in daily life. The solution of EMC must be addressed at the beginning of design phase of commercial building to reduce additional cost of EMC interface animation on device. Therefore, EMC solution is important. First, the component must be interconnected with low impedance with the module carrier to solve EMC problem. When assembling the module carrier, a fixed connection with good contrast between the individual sections is important. Material with a conductive surface is preferred to an isolating surface, such as anodized cloth. The connection between the test strip and the subframe is left to chance. When permanent the isolating anodized skin, a perfect connection to the frame is guaranteed. Besides, wire form a loose, max and efficient antenna to solve the problem EMC. The efficiency of any antenna can be optimized by the length of the shaft of the antenna for any given frequency. A good practice for minimizing the ability of an antenna to send or receive is to minimize the load. Unfit and return wires together rather than allowing a loop to form. Twisting the pair together further reduce the antenna effects. This also applies to potential within wiring. Antennas work equally well in both receive and transmit modes. In addition, use an electro-galvanized sub-panels instead of more common painted panel is one of the solutions of EMC. A glass sub-panel avoids the need to remove pans for bonding, with resultant long-term corruption potential and risking poor performance to solve EMC case. The EMC case have better RF shifting and fewer holes and shows. Holes in the valve page from displays, connectors and cables are a sources of emission. Therefore, special design for RF use to cover with no holes or holes with optimal splitting and achievement, with many screws for better RF shifting to solve the EMC case. The energized cord on the rear side of the front page is signed off. This result is a measurable connection from the front page of building. Check after the modification, not influenced by the ESD that the front page can pass the charge directly to the commercial building and does not radiate inside the device. That's all for me. Thank you.
Hi, my name is Numanul Mujahid bin Yusuf. My entry number is 201107. Now, I'm going to talk about the importance of EMC regulation in commercial building. So, what is EMC regulation? There are regulations or standards that is introduced by regulation bodies such as Federal Communication Commission (FCC) in USA and the Electromagnetic Compatibility Directive Europe, in order to limit the effect of electromagnetic interference. So firstly, the importance of EMC regulation in commercial building is to minimize the risk to the correct function of equipment and interconnected cabling from electrical hazard. In commercial building environment, the physical separation of high and low current cable is very important for EMC, particularly if low current cable are not shielded or the shielding is not connected to the exposed conductive parts. The sensitivity of electronic equipment is in large part determined by the accompanying cable system. If there is no separation of different type of cable in separate cableway, minimum or the minimum distance between high and low current cable, electromagnetic coupling is at its maximum. Under this condition, electric equipment is sensitive to EMC disturbance flowing in the affected cable. Next, the importance of EMC regulation in commercial building is to provide the telecommunication installation with a reliable signal reference which may prove immunity from electromagnetic interference. Communication networks are mostly extensive. They interconnect equipment located in different areas where feeding power supplies could have different earthing systems. If these different areas are not well equipped potential, harsh transient current could appear, such as lightning or main power fault, causing high voltage potential difference between the interconnected equipment. Communication interfaces like the board or the module could be disturbed or damaged by this common mode of voltage. The third importance of EMC regulation in commercial building is to protect appliances against voltage disturbance and electromagnetic disturbance, like natural occurrence such as lightning. Stray currents are inevitably propagated in an earthing network. It is impossible to eliminate all the sources of disturbance for a site. Earth loops are also inevitable. When a magnetic field affects a site, the field created by lightning, differences in potential are created in the loops formed by various conductors and the currents flowing in the earthing system. Consequently, the earthing network is directly affected by any practical measures taken outside the building. As long as the current flows in the earthing system and not in the electronic circuit, they will not do any damage. However, when earthing networks are not equipotential, such as when they are star connected to the Earth's electrode, the high frequency stray current will flow wherever they can, including in control wire. This situation can cause equipment to be damaged or even destroyed. And last but not least, The importance is to have a lesser risk of overvoltage. An overvoltage can be said as an electrical surge of a short duration with high energy impulse that is introduced into an electrical power system. Whenever there is a sudden change on the electrical circuit, it can originate from a variety of sources such as both internally and externally to a facility. The causes can include lightning, utility switching, and down power lines. They may even come from fax machine copies or other things surrounding the system. Properly sized and installed surge protection is highly successful in preventing damage, especially to sensitive electronic equipment. Moving on to the next part are the examples of EMC regulation in commercial building. The first regulation is the BSI. BSEN 50310, which is a European standard applies to the equipotential bonding inside the buildings, in which information technology equipment is going to be installed. And the next regulation is EN 50174, which has two parts. The first part of this regulation entails the specification and quality assurance in cabling installation. And the second part of the regulation is about the installation planning and practices inside buildings in cabling installation. And last but not least is HD 6464444 regulation. And this regulation is about protection against voltage disturbance and electromagnetic disturbance in low voltage electrical installation. That's all from me. Thank you.
Hello everyone, my name is Siti Asha Husna binti Muhammad Noor. My matric number is 200-982. I will conclude what we are already talked today about the EMC awareness program in the commercial buildings. So to design a commercial buildings, we must follow the legal requirement for EMC. EMC stands for electronic compatibility that concern about unwanted electromagnetic field that can cause interference. So we need to consider the generated electromagnetic environments internally and externally. It relates about two things, which is first is the electronic equipment, second is the working environments. So the goal of EMC, we want to correct the operation of different electrical equipments in the electromagnetic environments. So users must follow the legal requirements, so that the surrounding electrical equipments can work effectively and safely. So what we have in commercial buildings, such as Wi-Fi router, mobile phones, and many computers. So if the electromagnetic field exceeds the limit, it may interfere other electrical equipments in that buildings. And also, the wide range of electromagnetic field can affect the human health. Generally, commercial buildings is referred to the buildings for the commercially use, such as office and also shopping malls. So we know that it is also a workplace for us to work within a long time in a day. So it is important for us to follow the regulation and standard of EMC, as it affects the effectiveness of the electronic equipments and also our health.